So in lesson 1.1, we have two algebraic goals. Our first one is I can translate between words and algebra. I can make words into algebra, I can make algebra into words. And then I can evaluate algebraic expressions. So these were some of those first few problems on your pretest. And there were several people, I don't know if you noticed, right away in number 1, I X'd it wrong because, and I underlined the word expression, because people wrote equations. Anybody know when an expression has not, that an equation has? What's there in an equation that should not be in an expression? What do you think, Amber? Well, no, not necessarily. Would think, Connor?
Symbols.
No, not necessarily. Tessa? The equal sign. As soon as you put an equal sign in a mathematical statement, as soon as you put an equal sign, it is no longer an expression, it is an equation. So no equal signs in expressions. So at the end of the chapter, when you have an equal sign in something that tells you to write an expression, I'm going to have to be like, oh, dude. Expression equal to an expression. Expressions themselves, though, do not have equal signs in them. So we're going to start with vocabulary. So this is where your book might be helpful to you, or maybe you're pretty good at this. You can just give us a nice definition without the book. What's a variable? What's a variable? What do you think, Haley?
It's used when you don't know what a number is.
Okay, so what do we use when we don't know what a number is?
Like a P or an H.
So a letter, right? Yeah, so a letter to represent, to stand in for, whichever way you want to write it. A letter to represent an unknown, or let's say it like this, a value that can change. In other words, X is not always going to be the same in every expression. X is not always going to be the same in every equation. When we substitute X in, X can be a value that changes. It's according to what the situation is. Well, how many letters are there in the alphabet? 26. Well, some of those letters are kind of, even though the book will use them, tests will use them, they're kind of not very good because they look like some of our mathematical symbols. Give me some examples of those that we have to be really careful with. Alyssa, thanks. X, because X is also shown as multiplication. But here's the deal. Algebra loves X, so X is not going away. But what are we going to use instead of the X for multiplication? We're going to use the multiplication dot instead. So X, that's a good example of one, of a variable. Give me another variable that might be a good one to use, or probably you know that they use it a lot. Tessa? M, okay. Throw them out, class. Just Y.
B.
B. What's another? What happens when you use O?
Maybe it's 0, 0.
You might mistake it for a 0. What happens when you use a small L? You might mistake it for a 1. What happens when you use a T? It looks like a plus sign. So one of the things that we want to make sure that we do is we want to make sure that our variables look like variables. In other words, sometimes you may need to make them look italicized or cursive. Like I wrote in cursive over there for the goals. So we have 26 letters to choose from. So we're not going to list them all. Constant. What's a constant? A value that never changes, right? Something that never changes. So a value that does not change. If something's constant, it stays the same, doesn't it? Okay, a value that does not change. So in other words, give me some examples. What? Let me hear something. Come on. A value that does not change. How old are you? 14. Now 14 is 14, isn't it? Even if we rename it, what's another name for 14? Give me another name for 14. 14 over 1. 28 over 2. 2 times 7. There's lots of names for 14, but 14 only has one location on the number line, right? It's a value that does not change. Its address will always be between 13 and 15 on the number line on it. It has one address. It really has one value, okay? Give me another constant. Dylan?
15.
15, okay. Dylan must be 50. He wants 15, okay? Well, can we begin to list all of the constants? Can we? Do you think we can name all the constants? How about 1/2? Is 1/2 a constant?
Yes.
Yeah, even though it's got other names, does it only have one location on the number line? Yeah. How about this guy? Is that a constant? Yeah, even though it never ends, it never repeats, pi still is a constant. It's somewhere just a little bit to the right of 3 on the number line, isn't it? Okay, so constants are values that do not change. They can be decimals, they can be fractions, they can be that crazy term called pi, they can be the square root of 250, which is an irrational number. There's all kinds of constants. Okay, numerical expression. What's a numerical expression? What can't it have again if it's an expression? You can't have an equal sign. So here's how we're going to start. We're going to say a mathematical phrase. And by the way, just like in English, we have sentences and we have non-sentences. In other words, they're just they don't have a complete thought. A phrase is not a complete sentence. It's part of a sentence, right? So an expression is part of an equation. So we're going to say an expression is a mathematical phrase. Numerical expression. What do numerical expressions have in them? Numbers. Constants then, right? Can we call them constants? That contains constants. Is there anything else it can have?
Variables.
Can it have variables, a numerical expression? Look in your book, yeah? Can a numerical expression have a variable? No, I can't. Constants, Dylan?
Can contain constant or operations.
Yeah, and or operations. We're going to say and or operations. Operations, what are operations in the math world? Name some. Add, subtract, multiply, and divide. There's only 4 operations in the math world. Math, or add, subtract, multiply, and divide. So a numerical expression can have operations in it. It doesn't have to, but it does have to have constants. So give me an example of a numerical expression that we could write down. An example. 2 plus 2. Oh, the old good old common 2 plus 2. But do we put equals?
No.
No, then it would not be an expression anymore. How about just, because that would give one more day of this, like 62 for one more day. Is 62 a numerical expression?
Yes.
Yeah. Does it have to have an operation? No, it just has to have a constant. How about this? 3 pi, would that be a numerical expression? What's happening there? Multiplying. We have a constant 3 being multiplied by another constant pi. There's no variable involved, right? So there's all kinds of, how about, could we say that 2.5, 2 and 5/10, is that a numerical expression?
Our square roots. Like
Yeah. Square root of, what do you want to take the square root of?
2.
2. That's a numerical expression. ... There's so many of them we can't even begin to name them all. Okay. Well then how does an algebraic expression differ from a numerical expression? Connor?
An algebraic expression has variables.
Oh yeah, so we're going to say a mathematical phrase. We want to make sure we understand that it is not a complete math sentence, it's just a phrase. It does not have an equal sign. And I'm going to keep saying that. A mathematical phrase that contains variables. In other words, you know what? It has to. I don't care how the book states this. It has to have a variable or variables, or it is not algebraic. Now it's numerical. To differentiate it from a numerical expression, you throw a variable in it. So if it has to have variables, then we're going to say that it contains variables and or and or. In other words, it doesn't have to have these things, but it can. Constants and operations. So in other words, the things that make up a numerical expression, constants and or operations, they can also be involved in algebraic expressions. So what's the only difference between algebraic and numerical? Letters, variables, yeah. Examples, give me some examples. 2x plus 17. How about this? Would this be a algebraic expression? Why? Yeah, that's all it's got to have, right? It has to have a variable. It doesn't have to have anything else. Give me another one.
3m plus 7.
3m plus 7. Okay. Does it have to have just addition?
No.
Oh, we could have something like this. 2n. Would that be an algebraic expression? Yeah. Okay. So again, not only should we know, but we should be able to picture, we should be able to visualize, we should be able to write down examples of the vocabulary in mathematics. These are going to be huge words all year long. You need to know when they come across that you can give the definition and or give me an example at least. Okay? Questions on that? That's just the vocab. Because what we're practicing right here is one of the things that you should have had in your reading, the SQ3R method. There are going to be times you have to take your own notes, and I'm going to tell you to SQ3R a particular lesson in your notebook. And when you SQ3R, one of the things you want to make sure you include is the vocabulary and examples of it. Then, another thing that's important in this lesson that you would want to have in your notes are, since we have to translate between algebra and words, let's think of some words that go along with our operations. So addition. When you see this word or words, you say, oh, I better add. Give me some words. Sum. S-U-M, right? Yeah. S-U-M. Sum. The answer you get when you add. Okay? Give me some more. Increased by. 4 increased by 10. We know we got to add them together. Give me some more. That addition has a time. Plus. Plus. Oh, yeah. Don't forget the word plus. 3 plus 3. Okay? You know you got to add. What else? Oh, don't give up on me yet. Come on. Gee, find something in your book. Come on. Seriously, help me out here. Don't give up yet. What? Combined. Okay? But we wouldn't say 3 combined 4. What would we say? 3 combined with 4. So we're going to say combined with. Okay? Combined with. We gotta make sense when we're saying it. Okay? So combined with. Give me some more. Add. Okay, so we gotta make sure we use the word add, we use it properly, such as add 9 to 2, right? We wouldn't say 9 add 2 though, would we? Does that sound normal? Add 9 add 2? But add 9 to 2, does that make sense? Yeah. Okay, give me some more. Pardon? Put together. I have $100 more than you do. More than, right? So in other words, you would tell me how much money you have, I'd add 100 to that. So more than. Okay, that's a pretty good start anyway to a list. Let's move on to subtraction. Minus, I love that one. That was just, so typical. 20 minus 5, okay. We always subtract. Alex? Take away. 4 take away 2. Difference. In other words, the answer you get when you subtract. What's the difference? Okay? Less than. Oh, yeah. Something is less. So we say 4 less than 10. Oh. Makes me think of something.
Subtract.
Subtract. Okay, so we could say 4 subtract 2. We could use it that way. Oftentimes, students use words in between these, like, kind of improperly. Just make sure you when you say it out loud, it makes sense is all, okay? Tell me something about addition and subtraction. First of all, they're inverse operations of each other, right? One undoes the other. But tell me, does order matter in both of them? Does order matter in addition?
No.
Is 3 plus 4 the same as 4 plus 3? Yeah. So that order does not matter. Some of you in your pretest, you wrote the same thing twice. I said, B plus 3 is the same as 3 plus B. You know what, if you use the same word twice, addition, you just really have the same thing. Because order does not matter in addition. Does order matter in subtraction?
Yes.
Absolutely. So you have to make sure you're very careful when you state a subtraction phrase or a subtraction, you're writing the subtraction algebraic expression. Be really careful, okay? And your book will help you do that. Okay, let's go on to the other two operations, which are, what's the next one? Multiplication, give me some words. Multiply. Okay, do we say 4 multiply 3? We say multiplied by, don't we? 4 multiplied by. Let's use that instead. Okay, 4 multiplied by 3. Trinity. Times. That's the most common one, isn't it? 4 times 3. Jaden. Equal groups of. 4 equal groups of 3. I don't want equals, I want equal groups of. 4 equal groups of 3. We know we gotta multiply 4 times 3. Connor. Product. The answer you get when you multiply is called a product. If you see the word product, you know multiplication better be going on. Order matter in multiplication?
No.
A little bit. In other words, is 3 multiplied by 4 the same as 4 multiplied by 3?
Yes.
Then order doesn't matter, does it? So if you use the word multiplied by twice, with the same numbers, you're just telling me the same thing. Okay? What did I do? Oh boy did I ever. Good job, good catch. Mup? Okay. I'm mupping something, I don't know, I got this, whole new word going there, I don't even know what it is. Multiply by. Thank you very much. I do not want you to think I'm not a good speller, because I can't. Right? Oh. You lazy son girls. Okay. Can you think of any other words for multiplication? Well, maybe you can find some on your own and add to the notes. Division. Divide. When we say 4 divided 2, divide 2, divided by. Yeah, divided by. Let's see if I can spell divided right. Redeemed myself. Okay, divided by. Jaden. Quotient. Q-U. Oh, T-I-E-N-T, quotient. When we see the word quotient, we know there's a division problem going on. Give me another one. Or ones. Over. So 9 over 3 means that you're going to take 9 and divide by 3? Yeah? Order matter in division?
Yes.
9 over 3 isn't the same as 3 over 9?
No.
No, you're right, it isn't. Okay. So, again, it's going to be important that, and we have not by any means begun to exhaust the list of words that we can associate with operations, so make sure that you add to that list when you can, okay? Questions so far? Okay, well, here's the other thing we do when we're SQ3R, and if you look at example 1, find example 1 in the lesson. Example 1, they're doing an example of an objective. The objective is written right above example 1 in blue letters. What's our first objective? Yeah, look at there, I wrote it out for us. Translating from algebraic symbols to words. Here's what we're going to be practicing. So, on your own, I'll let you study example 1, but right now we're going to jump right to the check it out problems below the example, and we're going to do them. So, they're not going to be very useful in our notes without us having something to, to help show what our answer is for. So, 1A, what's happening in 1A? First of all, what are the directions? What are we supposed to do? Give 2 ways to write each algebraic expression in words. Okay, well, the first thing we better do then is write down the algebraic expression. It's going to be worthless without it being. And now we're going to give 2 ways And remember, order matters in subtraction, so we gotta be careful. Give me one way we could write this. 4 minus the number n. Okay? Right in that order, right? Okay. I want to use the words less than. Tell me how I can write this using the words less than. Mara?
4 less than n.
Everybody agree? That's one of the tricky ones. That's one of the tricky ones. That's why I picked on it. 4 less than n. This really says n less than 4. In other words, when you use the word less than here, it's saying that number in front is being subtracted from something. N is being subtracted from 4. So we have to be really careful in subtraction, okay? 1b, what's our algebraic expression? Let me see, I will write it down. You can write it down also. What does that, how could we write that in words, in a word phrase?
T over 5.
T over 5, okay. And we know that when we see the word over, we have to do what? Divide, okay, give me another one. Does order matter in division?
Yes.
T divided by 5, okay, well, I guess we can go with that. T split into equal, 5 split into T, equal groups of T. There's all kinds of ways we could write this. We just have to make sure that we understand what division means. Okay, 1C. Let's see, what is that one? Okay, here it is. It is. There's our algebraic expression. How can we write that as a word phrase? Okay, write down 2. Go ahead. Just do it. You pick your own 2. Pick your own 2. I'm going to pick my own 2. Order matter in addition? Hopefully you have 2 good ones. Maybe one gets checked out. Anybody just want to show off? Anybody want to speak?
9 more than Q.
9 more than Q, I like it. 9 added by the number Q. How about we do it this way? 9 added to the number Q instead of by. We don't add by something, we add to, okay? 9 added to the number Q, okay? Tessa? 9 increased by Q. So same thing that I had. Could it be Q increased by 9? Yes, because it's addition. Okay, let's do 1D. 1D is this right here. What's that say? It's multiplication, isn't it? So what are we going to write?
3 times h.
Okay, 3 times h. That seems easy enough.
The product of 3 h.
Oh, the product of. Because product means we're going to multiply. What are we going to multiply? We're going to multiply 3 and h. The product of 3 and h. Okay. Am I going to be picky about these? Absolutely. You're going to show me you know your stuff. Okay? Number 2, the next objective. Where are we going to find the second objective? Okay?
L.
Above what?
Check it out.
Above example 2. In what color lettering? Blue. What's the second objective? Translating from words to algebra. So going the opposite direction.
Max Cuban to the theory opposite mass.
Okay, now we're going to be translating from words to algebra, and we're going to go directly to, I'm going to let you study example 2 on your own. We're going to go directly to 2a, and we are going to do what they ask us to do there. We have Lou who is driving at 65 miles per hour, and we're going to write an expression for the number of miles that Lou drives in T hours. So we need an expression for the number of miles. Let's write that. Expression excuse me, for number of miles. What doesn't an expression have in it? Equal sign. You're supposed to be able to spit that out just like that now. Expression does not have an equal sign. Okay, so we are supposed to write an expression that represents the number of miles. Would anybody think they know what that expression could be? Tessa? 65T. Because 65 is what? How fast this person is driving, and what's the T? Yeah, so if you take rate times time, do you get distance, number of miles? 75 miles an hour on Interstate 94, 2 hours you drive, 75 times 2 equals 150 miles, right? So our expression is 65T. It's a numerical expression or an algebraic expression? Algebraic. We just wrote an algebraic expression. Okay, 2B. In 2B, we have Miriam, who's 5 centimeters taller than her sister, and her sister happens to be M centimeters tall. Write an expression for Miriam's height. Expression for Miriam's height. An expression does not have an equal sign. Okay. Write an expression for Miriam's height. How tall is Miriam? How tall is Miriam? Everybody? Huh? Huh? Let's try. Say it louder. 5 times M? 5 minus M. 5 plus M. 5 plus M. Or M plus 5, right? Because it does not matter in addition, because it says here that she is 5 centimeters taller than her sister. So she's got to add 5 to her sister's height. Her sister's height is M, right? Not 5 times as tall. Whew. Hopefully she's a baby then. Okay. 2C. Elaine earns $32 per day. Write an expression for the amount that she earns in D days. So 2C, we're writing an expression for earnings. Oh, not an S on that expression. Expression for earnings. Okay. Well, we know how much she makes per day. We happen to know that something's going to represent days. What are we going to write? 32D. We have to take 32? Yeah, she makes 32 per day and times the number of days. So 32D, multiplication. If we want to write that with the D first, I saw some people who thought you could do this, D32. No, that's in the science fiction world that we talk about things like D32s or whatever. If we want to write it with D first, we have to write it like this. Okay. Okay. Questions on being able to translate from words to algebra? Okay. Last page. Are we on? Right? Okay. Well, apparently they threw another vocabulary word in here. Evaluate. What's evaluate? Dylan?
Find its value.
To find the value. Okay? Is that all we need?
Find the value of an expression.
Yeah, find the value of an expression. In other words, evaluate. Find what that expression is equal to when you are given some information. To find the value of an expression. So we're moving into objective 3. What is objective 3? Evaluating algebraic expressions. Evaluating algebraic expressions. Oh, well, algebraic expressions right away, the first thing that should come to our mind is it doesn't have what? Equal sign, but it has to have a variable. Okay. So, oh, I wrote that. That's supposed to be here. Oh well, I don't know where I ran over. Evaluating algebraic expressions. Okay, check it out. We're going to to the bottom of page 7. Evaluate each expression for m equals 3, n equals 2. Okay, let's put that here. M equals 3, n equals 2, and then I can quit having to remember what it is. And p equals 9. So we're supposed to evaluate the first one, mn. So what do we do first? Substitute. We put 3 in for m and we put 2 in for n, and 3 times 2 is 6. Our final answer is 6, and that's called showing work right there. 3b. Now we have the algebraic expression p minus n. They were just too nice to you in these. P is 9, it says it right there. N is 2, it says it right there. 9 take away 2 is 7. So help me if you put your fingers to your calculator. Life is not good for you. Okay, 3c. My algebraic expression this time is p divided by m, which could also be written like this, right? Correct? Okay, so p is what? 9, and m is 3, and 9 divided by 3 is, oh my goodness, were they nice to you? Is 3 divided by 9 the same thing? What's 3 divided by 9? 3/9, also known as 1/3, okay. And our fourth objective will always, typically the last objective I should say, in a particular book will be application. So we're going to put application. Application is another way of trying to get by with saying, you know what, you're going to do a word problem. You're going to apply your knowledge to a word problem. Okay? So we are going to apply our knowledge to, we're going to do check it out. We're going to do check it out on page 8. So where did this come from? It came from page 8. And we are going to do what it says. It says to make one sweater, 63 20-ounce plastic drink bottles must be recycled. Well, it says write an expression for the number of bottles needed to make S sweaters. So the first part, A, is expression. So we need an expression. Remember, it can't have an equal sign. We wanted to represent how many bottles do we need for S number of sweaters. So what would that be? What would that look like, Mara?
63S.
63S. And so that it doesn't look like a 5 or something, I'm going to make a cursive S. It doesn't, look like some 63S. Take 63 because it takes 63 for one sweater, multiplied by how many sweaters you're going to make, and presto, you'll know how many bottles you need. B, we're going to evaluate. And we're supposed to evaluate it for when what? S equals what? 12. When S equals 25. When S equals 50. Okay, you can use your calculators. I'm going to do the math in my head because I didn't get to use calculators when I was in school. So 63 times 12. Okay, well, let's see. That would be 630 plus 630 plus another 126. So that would be 1260, 1286. I think I might have it. Is it 1386? Do it on your calculators. Am I right or did I? What's 63 times 12? 756. I was bad. Okay. I'm going to try again, though. You too. So 63 times 25. I'm going to try this again. 630 plus 630, that's 1260 plus half of 630 is 315. So 1275. 1575?
Yes.
Okay. And now I need to take 63 times 50. Well, I'm not going to work very hard because here I know I just have to double it. Oh, so that's going to be 3,150. Am I right? Check me out. Don't trust me. I can't be trusted. Jake proved me wrong myself. Is 63 times 50, 3,150, yes or no?
Yes.
Yes, what are these? Are these bottles or are these sweaters? Really? Okay, would you give every one of those a label? Bottles. You gotta know what that number represents. It is not sweaters, it is bottles. How many bottles are needed? Amen. Okay. I'm going to hand out your homework to you right now. You may do your homework right on the worksheet itself. Your notes show you what kind of work to show. So don't come back tomorrow saying, I didn't know what to do. I'm going to be like, well, your notes were a good example. Put your name on the top of it, and then it is assignment number 2, and that's about all you're going to have time to do. I will put this in your homework folder. And I will issue your assignment.